Question 4 is quite a complex question. It's 6 marks in total, and it says this question is about elements in periods 3 to 4 of the periodic table. The table shows the melting points of elements in groups 14 to 17, or 4 to 7 if you prefer. Gives us some information about phosphorus and sulfur in terms of how they exist as P4 and S8 molecules, table of data for melting points, and then it gives us 2 things to do. So the first thing it asks us to do is explain the trend in melting point from silicon to chlorine across period 3. So that's focused very much on period 3, the command word of explain. And then the second thing is comment with reasons on the similarities and differences in the trends across period 3 and period 4. So we're basically comparing period 4 to period 3. And quite an unusual command word, comment with reasons on the similarities and differences there. In terms of the key information in this question, well, obviously if it tells us something, we're probably going to need to use it. So the fact that phosphorus exists as P4 and sulfur as S8 will no doubt come into our answer somewhere. And the only other thing really to focus on is make sure we do both of these different things that it's asking us to do here. Linking back to what we've learned, this is a bonding and structure question, so we need to be really clear. Once we talk about melting point and start to explain why melting point is what it is, we need to be, it's all about the strength of the bonds in the substance. So in this case, what kind of structure are we talking about of our 4 options, which are ionic, simple covalent, giant covalent, and giant metallic. So we need to decide for each of these which structure we are talking about. When we structure our answer, the question is actually set out quite nicely with the 2 bullet points, which gives us the structure. I'll tackle the first bullet point first, and then move on and talk through the second bullet point. So let's have a go. We're going to start with the first bullet point. Explain the trend in melting point from silicon to chlorine. Right, I'm going to start with silicon. So in period 3, silicon has a high melting point. So I'm showing that I recognise that 1414 number is a high number, as it is a giant covalent structure. So a clear statement as to what type of structure it is, but I haven't really explained why that means it has a high melting point. So I have to go on and say it has with strong covalent bonds between the atoms. Really important here that we get our terminology right. These are covalent bonds between atoms. Still not quite finished the explanation. So what? They requiring a lot of energy to break them, which explains why we need to heat it up to high temperatures to break those bonds and therefore melt the substance. Phosphorus, sulfur and chlorine, I can lump all these together because they're all the same type of structure. So they are all simple molecular substances with low melting points because the intermolecular forces, in this case between the molecules, are weak, so needing little energy to overcome them. Okay, so we've explained why silicon is high and why the other 3 are low. What I haven't done yet is used my understanding that phosphorus comes in groups of 4, sulfur in groups of 8, and I know that chlorine comes as pairs of atoms joined together, to explain why phosphorus has a melting point of 44, sulfur is higher, and chlorine is lower. So we're going to move on and look at that. So we're going to say, of these, sulfur has the highest melting point because the S8 molecule is the largest with the most electrons and therefore the strongest intermolecular forces. And it's just struck me, intermolecular forces is probably a bit vague at A level, so I'm going to show that I know what kind of forces they are, London forces. And then that's followed by P4 and then Cl2. So that's the bulk of this question. That's just that first bullet point looking at the trend in melting point from silicon across to chlorine. So the second bit asks me to look at period 4 and look at the similarities and the differences between period 4 and period 5. So in period 4, germanium is similar to silicon and selenium and bromine are similar to sulfur and chlorine as they have the same structures. However, and this is the one that's different, arsenic has a higher melting point than phosphorus as it has a giant covalent structure. So absolutely key with questions like this is terminology. It's really easy to get confused between ions, molecules and atoms. The one that really catches people out is they talk about molecules. You can only talk about molecules for simple molecular substances. If we have an ionic substance, a metallic substance or a giant covalent substance, then we have to be talking about ions or atoms and not molecules. So we need to be really careful with that.